All right, in this question here, we're given the integral from 0 to 5 of f at x dx is equal to 10. And what we want to discover is what is the integral from 0 to 5 over 2 of x plus f at 2x, again with respect to x here. So let's take a look at this problem here. First thing we want to do is I can go ahead, we're going to, again, use this fact, hopefully at some point in the question, we're going to have to. So I'm going to break this up first. So this will break up into the integral from 0 to 5 halves of x dx plus the integral from 0 to 5 halves of f at 2x dx. And again, that is the result of your integration operation being applied linearly to an expression. So I can apply it to each sort of one of these terms here. And advantage here is I know what this is. This will be the integral of x with respect to dx is x squared over 2. And I'm evaluating that from 0 to 5 halves. So that portion is easy to calculate and done. For this portion here, what we want to do is I'm going to go ahead and make a quick substitution. I'm going to let t equal 2x, in which case I know that dt is going to be 2 dx, and therefore 1/2 dt is dx. So now I know that 1/2 dt is dx. Now, I have to change the integration. This is with respect to x, these values. I need to change them with respect to t. So when x is 0, if I let x be 0 here, t is still going to be 0. So we're still not changing that bottom one. However, when x is 5 halves, I'm going to get a t value of 5 this time. And again, when you sub 5 halves into here for x, your t value is going to change. So now when I do my integration sign here, we have to change the bounds here. It's going to go from not from 0 to 5 halves, it'll go from 0 to 5. This will be f at t, and then I'm replacing the dx with a 1/2 dt. Again, doing a substitution here. So to clean this up here, I can now evaluate this itself. So this will end up being 5/2 squared over 2 minus 0 squared over 2. That'll be that chunk there. Plus, I can pop the half out. This will be the integral of 0 to 5 f at t dt. So closer examination of this, we know that this, in fact, was given to us in the question. And I know the integral from 0 to 5 of f at x dx, or f at t dt, makes no difference, is equal to 10. And therefore, I can write this back down here. This becomes 5/2 squared over 2 minus 0 squared over 2. And this, we get our 1/2 again. And this we can replace with a 10. So I can just simplify this, and this should get us to our answer here. So 5/2 squared is going to give me 25 over 4 divided by 2. This would just be minus 0, and that's plus 5. So this will end up being 25 over 8 plus 5, which is 25 plus 40 over 8. And the final answer for this question is 65 over 8. So therefore, the integral of from 0 to 5 halves of x plus f at 2x dx, given the following above, is equal to 65 over 8. Thank you.